Database is an important concept no matter which industry you belong to. Engineering to industrialization, digital to medical, every organization needs database. Database can store very large number of records efficiently, and it is very easy to add new data and edit or delete your old data. With that, I, Bhavita, welcome you to today's session on SQL versus MongoDB. But before we get started, let's look into the agenda for today. We'll have a brief introduction on databases. With that, we'll understand what is MySQL. We'll also understand what is MongoDB and then jump into the differences in regards with the features. And then we'll see which is better to choose. Now let's get started. Now, as I've already mentioned, database is one of the important things used in any kind of organization. Typically, database is defined as an organized collection of structured information or data, and it can store electronically in a computer system. Of course, it has evolved over the years while it was manually done. Even that by concept is known as database. Databases are more complex than they appear in some cases. They are often developed using formal design and modeling techniques. It is usually controlled by database management system. Now, although together data and DBMS along with the application that are associated with them are referred to as database system, it is often shortened as database. Now, monitoring or tracking of database performances and resources are most important thing while you create an important database. Now, database systems are very important to your businesses because they communicate information related to your sales transactions, product inventory, customer profiles, and marketing activities. With that, let's jump ahead and see what are some of the advantages of using database. The first thing is it is extremely easy. When I mean easy, it is easy to research data or update data or even delete data for that matter. This is because there is something called as data manipulation languages available in your database. And even in research part, there is something called as data query language which allows you to search any data in the database and it'll help you perform complex operations. The next thing is data security. Now, databases have various methods to ensure security of data. There are user logins required before accessing a data and various access specifiers. These allow only authorized users to access the database. The next thing is there is a uniform data management and administration. Say, for example, you have to manage a large amount of data. A database stores and manages a large amount of data on a daily basis, and this would not be possible using any other tools such as your spreadsheet, as they would simply not work. The next thing is to access and audit your data. Now, due to the accuracy of your data, it is pretty easy to access or even integrate or audit your data. It will ensure many constraints are being considered. The next thing is to understand types of databases used for storing your data. The first thing we have here is centralized database. Centralized database is a database that is located, stored, and maintained in a single location. And this location is most often a central computer or database system. For example, your server CPU, your mainframe computer. The next thing is distributed database. Distributed database is a database that consists of two or more files located in different sites, either on the same network or entirely different networks. Next, we have relational database. Relational databases have been named since 1970s. The relational database management system is the program that allows you to create, update, and administer a relational database. Structured query language is the most common language for reading, creating, and updating or even deleting data. Organizations have used relational database over the years, and most important example of relational database is MySQL. The next thing is cloud database. Cloud database refers to any database that's designed to run in the cloud. Like other cloud-based application, cloud databases offers flexibility and scalability along with high availability. Cloud databases are also often low maintenance since many are offered via SaaS model. And again, one more example for cloud database is Microsoft Azure SQL. The next thing that we have is object-oriented database. An object-oriented database is based on object-oriented programming, so data and all of its attributes are tied together as an object. Object-oriented databases are managed by object-oriented database management systems. These databases work very well with object-oriented programming language such as C++ and Java. Next up, we have hierarchical databases. Basically, these use parent-child model to store data. And if you were to draw a picture of a hierarchical database, it would look like a family tree with one object on top branching down to multiple objects beneath it. Now, IBM is one of the main examples of hierarchical database. The next, we have network database. It is a type of database model wherein multiple member records of files can be inked to multiple owner files and vice versa. The model can be viewed as an upside down tree where each member information is the branch linked to owner, which is the bottom of the tree. Next thing is NoSQL database. NoSQL is a broad category that includes any database that doesn't use SQL as its primary data access language. These types of databases are also sometimes referred to as non-relational databases. One of the main examples are Apache Cassandra. With that, let's understand what is MySQL. As the name suggests, MySQL stems from structured query language. This basically means that here the database is a structured collection of data. Typically putting into definition, MySQL is a relational database management system developed by Oracle, which is based on structured query language. So basically, MySQL database service is a fully managed database service to deploy cloud-native applications. Now they can be from your Microsoft, Linux, or even Solaris. Here are some of the features of MySQL. Firstly, it is an open source application. With the flexibility of being open source, you can use them or anyone can typically use them. The next thing is it uses a relational database management system, which is based on SQL, that is structured query language. It is one of the most popular languages for accessing and managing the records in the table. And like I mentioned before, SQL is an open source and free software under GNU license. Oracle company basically owns it. Oracle has also developed SQL. The next thing is connectivity. Due to its high compatibility, it has high connectivity. And this feature improves the performance and provides fast management of large database. The next thing is low cost. Due to the affordable prices and strong performance, MySQL is highly preferred. Next, due to the scalability and flexibility of MySQL. MySQL supports a large number of embedded applications, which makes it very flexible, while it supports multi-threading that makes it easily scalable. The next is tools. Few of the MySQL tools are Microsoft SQL Server Management Studio, MySQL Workbench, DB Visualizer, Oracle SQL Developer. Now these tools help you perform different kind of operations with different circumstances. And finally, security. It is highly secure, and like I just mentioned a while ago, MySQL consists of solid data security layer that protects sensitive data from intruders. Also, passwords are encrypted in MySQL. The next thing is to see the components of SQL. First things first, we have data manipulation language. Data manipulation language consists the subset of SQL commands used most frequently, those that simply manipulate the contents of database in some form. For most DML or data manipulation language commands retrieve information from a database, which is select operation. The next thing is to add new information, which is insert operation. And the next one is to update your information, which is update command, and then remove the information, which is delete command. With that, we shall see the next one, which is data definition language. And this contains commands that are less frequently used. DDL commands modify the actual structure of a database rather than the database contents. Examples of common use DDL commands include those used to generate a new database table, which is create table, or modify the structure of the database table, which is alter table, perhaps even delete the database table, which is drop table. The next thing we have is data control language, shortly known as DCL, which is used to manage user access databases. It contains two major commands, which is grant command, used to add database permissions for a user, and the revoke command, which is used to remove existing permissions. With that, there is something called as transaction control language, which involves commands which are used to manage transactions in the database. These are used to manage the changes made by DML statements. It also allows statements to be grouped together in logical transactions. Next up, finally, we have data query language. Data query language is a specialized programming language for searching and changing the contents of a database. Now, there are also query languages which involves many other operations, but data query language is one of the main SQL languages. Now, we have learned enough about SQL. We shall next learn about MongoDB. MongoDB is typically an open source NoSQL database management program. NoSQL is used as an alternative to traditional relational database. NoSQL databases are quite helpful and useful for working with large set of distributed data. And MongoDB is a tool that can manage document-oriented information, store, or even retrieve information. MongoDB basically uses JSON-like documents, which involves no SQL, and hence it is also a source available cross-platform document-oriented database program. Now, typically, let's examine the features of MongoDB. Now, GridFS is a feature which will allow the files to divide into smaller parts and store them in different documents without complicating the stack. Next, we have shredding, which is an auto-shredding. The data is being distributed among several physical partitions known as shreds. MongoDB has an inbuilt feature called automatic load balancing. The next thing we have is document-oriented storage. It uses BASIN format, which is similar to JSON. JSON format being JavaScript object notation. The next thing is replication. MongoDB possesses master-slave replication. It uses a native application to preventing database downtime by maintaining multiple copies of data. Now, what exactly is indexing? Well, all fields in the document are basically indexed. The next thing is high performance. Now, as we've already seen, the growth of our database, usage of MongoDB increases the performance rapidly, since this is the latest and more advanced tool in our database. Ad hoc queries, which basically means MongoDB supports ad hoc and document-based queries. Now, finally, we have aggression. Aggression, which means procedural based. MongoDB JavaScript works better than procedures as database used the language more than procedures. With that, let's see the architectural diagram and components involved in MongoDB. Now, in components, we have database, collection, and document primarily. Database, as we've already encountered, It is called the physical container for data here in MongoDB. Every database has its own set of files existing on the file system. In a single MongoDB server, there are about multiple databases present. Speaking of collection, it consists of various documents from different fields. All collections reside within one database, and in collections, there are no schemas present. Finally, we have document, which is a set of key values which are assigned to document, which is in turn associated with dynamic schemas. The benefit of using these schemas is that a document may not have to possess same fields, whereas they have different data types. With that, let's jump into the key features by which we can differentiate both MySQL and MongoDB. The first thing is differentiation in terms of language. As we've already established, MySQL uses structured query language as MongoDB uses JSON data. The next thing is to differentiating via schema. Both SQL and MongoDB is quite a rich query language supported tools. MySQL, like many relational databases, are structured query language for access and represents data in tables and rows, while MongoDB uses MongoDB query language designed for ease of developers. Now this basically uses data modeling technique. Now data modeling is where typically you don't have to have the same kind of data in your database. The next thing is data structure. As established already, MongoDB will be faster as it has ability to handle large unstructured data, while MySQL uses typical structured form of data. Now it stores each individual record as a table cell with rows and columns. The next thing in data structure is that MySQL uses relational type of database. Now it is quite traditional and it can be used only for a relational type of database, while MongoDB can have extreme and potential growth as it allows unstructured type of database to be used. The next thing is storage of data. Here, in comparison, MongoDB is faster than MySQL. Now this is because of its ability to handle large amount of unstructured data when it comes to speed. Now it uses slave replication, master replication to process vast amount of data, rather unstructured data. MySQL does not qualify for in-memory database. Now community support. MySQL was originally developed by Oracle and is still maintained by Oracle Corporation, while MongoDB has its own corporation and which is known as MongoDB. It was also established by its own corporation. With that, we'll come to the last topic, which is to understand which to choose, or rather, which is a better database language. Now, in conclusion, it is fair to say that SQL database is more suited for businesses and industries that deal with structured and relational data. It is great for websites with high traffic and facilities, a high-performing query engine. Data insertions, specialization, web functions, quick processing, and robust reliability are some of the best features offered by SQL databases. So, I highly recommend if you're using relational database as the main structure for your company, then SQL should be chosen. While speaking of MongoDB, it can be used by businesses and organizations of all size who are looking to scale out huge volumes of traffic as well as data. If you desire great speed and certain flexibility with the use of unstructured data within a schema-less environment, MongoDB is your go-to. An element of automation with these databases can improve the functionality of your system even further. With that, I conclude this session. If you have any doubts regarding today's session, do let me know in the comment section below. I hope you have enjoyed today's session. Until we meet again next time, happy learning.